Hey guys, hoping all is well with everyone. So in this video, we are going to be looking at our question of the day here that I was recently inspired by. And we're here asked to be solving the equation 12.6j plus 8 is equal to 10.2j plus 4.4. Now, one of the reasons this equation particularly inspired me is that normally this is probably going to be asked of you in the latter section of solving equations with a variable on both sides, which is totally applicable and appropriate to the question we see at hand here. However, in looking at this, there is a lot that is thrown at you when you just look at this equation right off the bat. Not only are you looking at an equation that has a variable on both sides, you're also looking at the component of decimals, which a lot of students aren't comfortable with or find it friendly in general. And you're also futuristically looking at operations that involve the addition and subtraction of positive and negative numbers. So it can be very overwhelming very quickly, but the guidance that I give to this question in terms of solving it is keeping track of everything step by step and taking it one step at a time. That allows you to kind of keep track of what is happening to each and every thing in terms of the operations you are applying, and keeping in mind of the bigger picture that in the end we are just trying to have one single variable all by itself equal to one finite value. So the first step that I'm going to take here in the approach to that big goal is to first start by getting the variable on one single side of the equation. And the way that I'm going to do that is subtract 10.2j from both sides. So get all variable terms on one side of the equation by subtracting 10.2j from both sides. Now, right off the bat, we kind of apply that balanced scale kind of analogy. So remember, when we are trying to solve equations, we have to apply operations to both sides in order to keep the equation balanced or equal. So I'm going to go ahead and subtract 10.2j on both sides. And then in my next step, I'm going to simplify both sides of the equation by combining like terms. So here, we're going to go ahead and on the left side, we'll get that 12.6j minus 10.2j. So that's going to give us 2.4j. So when it comes to combining like terms here, a couple of rules. The first one is that for the intents and purposes of this question, all your constants are like terms, so the numbers without variables. And then all terms that involve the variable j are also like terms. So when we take that operation of subtracting, we just subtract the coefficients, giving us that 2.4j plus 8 is equal to, you're going to notice here that the 10.2j minus 10.2j, it essentially cancels itself out. But what you can do for housekeeping is represent that with a 0. And that just kind of allows a student to see where those terms are going, to relieve a little bit of anxiety if they see that a term is disappearing. But again, in the reality of it all, we want that cancellation to happen because it gets us one step closer to solving for our variable that we are looking for. So I'm going to simplify this one more step by just accounting for that 0. So we have 2.4j plus 8 is equal to 0 plus 4.4 is just 4.4. Oops. So the next step that we have is we've accomplished getting the variable on one side of the equation. So that's already a big goal accomplished right there. So now it comes back to the overall goals of isolating the variable and having it start to just equal one finite value. Now when a student looks at this step, they kind of refer back to their order of operations. So they'll tell themselves, okay, so if I want to look at the operations here at hand, j has 8 being added to it and 2.4 being multiplied by it. So in order of operations, multiplication and division trump addition and subtraction. So since j is being multiplied by 2.4, I have to undo that operation by dividing 2.4 on both sides. Now, all of that was just said is completely accurate and correct. However, I will give the guidance that it can get a little messy, but very quickly. Because when you divide both sides by 2.4, you have to divide all the terms by that. So you're going to get 2.4j divided by 2.4 plus 8 divided by 2.4 is equal to 4.4 divided by 2.4. So that can get really involved, and if you're not a big fan of decimals, it can be a little overwhelming. So the way that I'm going to approach this is this idea of reverse PEMDAS. It's basically undoing the addition on 8 first, then dividing both sides by 2.4. Now, in retrospect, I don't solve my problem of avoiding negative or avoiding decimals, but the decimals that I get are going to be much cleaner. So step 3 is going to be begin to isolate the variable by subtracting 8 on both sides. So here we'll have 2.4j, and then step 4 is going to be kind of that simplification step again. So simplify both sides of the equation by combining like terms. So we have the 2.4j, and again, this plus 8 and this minus 8 will cancel, but again, if you want, you can definitely use that 0 as a placeholder. Nothing wrong with that. And then you come to your first kind of elephant in the room with this question. You have the addition of positive and negative numbers that also look at a decimal component. So it's not the friendliest thing, but again, this is where the beauty of taking multiple paths in solving something with what is most comfortable for you. So in this type of arithmetic, you are looking at one of two things, and again, this kind of is based on your comfort level with decimals and negative numbers. You can look at it as positive 4.4 minus 8, or you can look at it as negative 8 plus 4.4. When you do the arithmetic here, you will get that difference is going to be negative 3.6. So if I took the difference in this first case scenario versus the sum. So now I'm going to take this and simplify it one more step. So I have kind of that understanding of the addition of 0 just being 2.4j. And now I have it equal to negative 3.6. So we're almost there. We are almost there. Our last step is going to be to completely isolate our variable by doing that division of 2.4. So if we apply that, 2.4j divided by 2.4 is equal to negative 3.6, negative 3.6 over 2.4. Now, on the next step here, you're going to do that simplification step. By simplifying both sides. So the way that we're going to do that is 2.4j divided by 2.4 is going to give us 1j. So, or j. Remember that anything multiplied by 1 is just itself. So we have accomplished our goal of getting j by itself. But there's another elephant in the room here, and it's going to be the fact that you have a quotient of 2 decimals. And not only is it that you're dividing decimals, you're also looking at dividing a negative by a positive. So unfortunately, you would not likely see an answer like this in an answer pool if it was a multiple choice test, and you would likely get pinged or points off if you left it in this way, because more than likely the question will instruct you to solve it and give the final answer in as a fraction or as a whole number. So when I say fraction, it's a ratio of 2 whole numbers. So the way that you can troubleshoot this is, if you didn't want to do the long division, which again with decimals can be a little bit overwhelming, is you can multiply both the top and bottom of this fraction by 10. And the way that that's going to help you is it's going to move the decimal over each number to the right, making them each whole numbers, being negative 36 over positive 24. Now, this is a much friendlier fraction to simplify or reduce, because what we can do is determine their greatest common factor and then divide that by a common ratio. So taking an extra step here, step 7, simplify the fraction on the right by multiplying both sides by 10, then dividing by GCF, or greatest common factor. Now remember, an approach to your greatest common factor, you can use factor trees, but in this case it's going to be 12 here. So remember, on our left side, J is all good to go. J is by itself, so we're in good place there. And then I'm just going to simplify this fraction a little bit more by dividing both top and bottom by 12, and that's going to give me negative 3/12. So a couple of questions that usually pop up here. Oops, sorry. Negative 3 over 2. So 24 divided by 2, or 12, is 2. So one of the biggest questions here is what happened to the decimal? Well, by taking that common ratio and multiplying by 10, we kind of eliminated it. So we don't have to really deal with it anymore. If you were to do the long division of negative 3.6 into, sorry, this is positive, into positive 2.4, you would get a result of negative 1.5. So in this case, I kind of took the pathway of just eliminating the decimal component of what the remainder of our question is, and then just made it a simpler fraction to simplify. So, and again, it comes down to taking the paths that are most comfortable for you. But as you guys can see, with these steps, there's a lot that happens pretty simultaneously in each of the steps that we take. But again, keeping track of your signs on each of your values and the rules of combining your like terms are just biggest things to keep in mind here, and the red flags to look out for. But I hope this helps you guys out. If you have any questions, or if you have a approach that is very different from the one I took, I would love to see it. I like to see how students kind of look at problems and solve them from multiple perspectives. If you guys did enjoy this video, feel free to like and subscribe. I take requests from students all the time, and that's where this equation was inspired from. But I hope you guys are all doing well. Please take good care of yourselves and be safe, and we look forward to seeing you guys next time. But thank you so much for watching. Bye.